All right, greetings YouTube, beautiful mind here. All right, so this is week 6 Monday for applied statistics. So we're kind of entering the home stretch. So we have actually done, like, I guess because of the dynamics of, doing video lectures and teaching online at home and stuff like that, we're actually going beyond where I've kind of wrapped up with my other students in the past, but we were in person, so that it had a different dynamic. And I do realize it's a lot of work. So we can do the following. I've been thinking about it and like how I kind of wanted to address the dynamics. So I'm open to the following idea. We'll go ahead and make chapter 6 the last of the new material. Okay, so it's only 4 sections, so we'll probably just do a section a day until we finish. That'll get us into week 7. Let's see. So for this week, I think I've already loaded exam 3. I loaded it last week sometime, so you have a full week to work on exam 3. I'm open to the following. So once we finish chapter 6, I'll probably will go ahead and load all the homework for chapter 6. And I might go ahead and load the final exam. So I might give you like a week or 2 weeks, maybe 2 weeks to work on the final exam. Also, I'm open to the idea of reducing the late penalty for the old assignment. So instead of being a 20% late penalty, I might reduce it to a 10% late penalty. So that way the highest you can get, even on exams, I might make it where the highest you can get on old assignments is an A. I want to get as many things loaded as soon as possible to give you as much time to work on these things. The closer we get to deadlines, the worse it's going to be. Like, Pearson is probably going to shut down and lock up. I'm going to make everything due that Saturday, May 16th, and our last class is the following Monday. So I might extend the final exam to that Monday, to the end of class time on Monday. But when class ends on Monday, we definitely have to finish everything. So all assignments are going to be due that Saturday, May 16th, and I'm probably going to extend the final exam to the close of class on that Monday. But I'm going to go ahead and load all assignments. I'm thinking about because it's basically just chapter 6, and then reducing the late penalty from 20% to 10%. So that means you can honestly still get an A on everything. It's a lot of work. I know it's a lot of work, okay? And you just have to do the best you can. But we're in the home stretch. You have to keep in mind that we didn't come this far to just come this far. You've been working really hard, and I can tell, okay? So just buckle down. Go ahead and get it done. I mean, it's doable. It's very, very doable, okay? You have support. The tutors should be able to help. Make use of the Ask My Instructor. Just keep pressing hard, okay? We'll go ahead and work on chapter 6. We'll do a section a day until we get to the end. It's only 4 sections. Again, that'll get us into week 7. Also on Moodle, there is an assessment. Be sure to get the assessment submitted. It's you get 1 attempt at it. I think it's timed as well. So just do the best you can with the assessment, okay? Again, I am available for questions. So the extension probably will be granted. We're going to, again, like I said, we're going to make chapter 6 the last of the new material. We'll get as many, I think everything else is loaded. All I really plan on doing is going through and reducing the late penalty from 20% to 10%. So you can still get an A on any assignment that you like. But keep in mind that the time for the quarter is running out. The quarter ends the Monday after, for this class, it ends that Monday after May 16th. So I think it's like May 18th is our last day together that we need to kind of be engaged. Okay, so we'll go ahead and take some time to go through chapter. We'll take some time to go through chapter 6. Keep in mind, this is my first time discussing this chapter, so if I make mistakes, you just have to kind of bear with me. But this will be chapter 6 will be the last of the material that should get us into the beginning of week 7, and then for the remainder lectures, I'll just be available for questions. Like I've been available for questions up until now, but I didn't really want to do more new material. I just wanted to get assignments loaded, and just be available to answer questions. And you can ask questions on anything that you want. Anything like homework, exams, it's all the same to me. Okay. So with that, let's go ahead and take some time to go through, take a look at chapter 6. So we're going to take a look at chapter 6 on confidence intervals. Okay, so we'll start with section 6.1, confidence intervals for the average or for the mean for a sigma known, where we know the standard deviation. Okay. So some objectives for 6.1, how to find a point estimate and a margin of error, how to construct and interpret confidence intervals for the population mean when the standard deviation is known, when sigma is known, how to determine the minimum sampling size required when estimating a population mean. Okay, so these are the objectives for 6.1. So first, let's look at this notion of what do we mean by a point estimate for a population mu, or the population average. The point estimate is a single value estimate for a population parameter. Remember, a parameter is just a numerical representation of a population statistic or a population characteristic. So it's a single value estimate for a population parameter. This is the most unbiased point estimate of the population mean mu is a sample mean x bar, right? So we have a population, and then if we take a sample, like say we have a population, I don't know, some really large number of population, right? And then the sample, we're going to take a subset of that population, and then we take the average of that sample. So the most unbiased point estimate of the population average is the sample average, right? So let's see, the estimate of the population parameter is going to be the average mu. So mu is going to be an estimate for the population mean, and we're going to use the sample statistic x bar. So we can have a sample and find the average of the sample and use it to estimate the population average. So let's look at this example on point estimate for a population mu. A researcher is collecting data about a college athletic conference and its student athletes. A random sample of 40 student athletes is selected, and their number of hours spent on required athletic activities for 1 week are recorded. Find a point estimate for the population mean mu, the mean number of hours spent on required athletic activities by all students in the confidence interval. Okay, so this came from Penn School in Berlin. So the number of hours spent. So say we have 40 students. We have these 40 students, and these are the hours spent by each student. And it says find a point estimate for the population mu. All right. So if we have this sample, we can use the sample mean x bar to estimate the population mean. So it says the sample mean of the data is given by this. We basically add up all the x's and divide by the number of entries. So if we add up those x values, they should add up to 842. Okay. And then we have 40 data points. So 842 divided by 40 is about 21.1 hours. So that's going to be the sample average. The point estimate for the mean number of hours spent required by athletes by all students in the confidence is about 21.1 hours. So we use the sample average to estimate the population average. Okay. So interval estimate. An interval or range of values used to estimate a population parameter. Before finding a margin of error for an interval estimate, first determine how confident we need to be that our interval estimate contains the population average. Before finding a margin of error for an interval estimate, first determine how confident we need to be in our interval estimate contains the population average. So again, we have this population, and we're going to be taking several samples. So when we find the average of the sample, there's a confidence interval that the population average, whatever the actual population average is going to be in a certain amount of our samples. I think that's the gist of it. Let's kind of keep going. So a level of confidence. The probability that the interval estimate contains the population parameter, assuming that the estimation process is repeated a large number of times. Okay, so that was the level of confidence. Again, this is the likelihood that the interval estimate contains the population parameter, assuming the estimation process is repeated a large number of times. So I think that may have been the thing that I didn't mention in the last slide, is that this process has to be repeated a large number of times. So critical values are going to be values that separate the sample statistics that are probable sample statistics from those that are improbable or unusual. So critical values are sample statistics. Critical values are values that separate sample statistics that are probable from sample statistics that are improbable or unusual. Okay. So for instance, say we have like the standard, the normal curve. So say we want a confidence interval of 90%. Let me see, I think it's a C, right? Yeah, a level of confidence. We have a 90% confidence interval, right? So that's going to be the area in blue we see here. So then if the blue is 90%, then that means the two yellow halves together make up 10%. So that means each of the yellow halves make up 5%. So we have 5% on the left, 5% on the right. Okay. So then the critical values separating, these are going to be like the negative Z sub C, that's going to be the left critical value separating the left tail. And then positive Z sub C is going to be the right critical value separating the right tail. So we have the improbable events or unusual events on the far left and right. And then you have the probable events in the center. Okay. If the level of confidence is 90%, this means that we are 90% confident that the interval contains the population average. Okay. So there's a 90% confidence interval with our improbable events on the left and right. So then there are corresponding z-scores with the 90% confidence interval. The corresponding z-score are plus or minus 1.645. Whatever, based on whatever given data. So the z-scores, there's a chart. Let's jump over to that chart actually. So let's see, it should pop up, right? So this is table 4 in appendix B in the back of our text, and we have this thing here for confidence interval. Let me see if I could just go like this. So then, for instance, if we want a confidence interval of 90%, then the z-score is going to be plus or minus 1.645. If we want a 95% confidence interval, the z-score needs to be 1.9 plus or minus 1.96, so on and so on. All right. Okay, so we will use that chart to determine the z-score, the corresponding z-score for whatever confidence interval that we would have. I gotta go through this again. Give me just a moment. What? Hello? Why does it keep displaying like that? All right, sorry about that. So we're back. Okay, so we talked about how to find those corresponding z-scores, getting them from the chart. So let's see, this notion of sampling error. This is going to be the difference between the point estimate and the actual population parameter. So for the population average, the sampling error is the difference between the sample average and the population average. The population average is generally unknown. The sample average varies from sample to sample. Okay. So then the margin of error, sometimes called the maximum error of estimate or error tolerance. That didn't display properly. That's okay. The greatest possible distance between the point estimate and the value of the parameter it is estimated is denoted by E. So that's the margin of error for the population error for a known sigma. So the margin of error is going to be the critical value times, what is that? This the sample error, right? Or the sample standard deviation. And I think last time we said that's going to be the population standard deviation over square root of n. Again, this is for a known standard deviation. So the sample is random and the population is normally distributed for n greater than or equal to 30. Okay. So let's look at this example on finding the margin of error. Use the data in example 1 and a 95% confidence level to find the margin of error for the average number of hours spent on required athletic activities by all student athletes in the confidence. Assume that the population standard deviation is 2.3 hours. Okay. Because the standard deviation is known, let's see what it said. Population standard deviation is known. Okay. The sample is random and n is equal to 40, which is greater than or equal to 30. Use the formula for E given. The z-score that corresponds to a 95% confidence interval is 1.96. Again, we got that from the chart that you saw a moment ago. This implies that 95% of the area under the standard normal curve falls within 1.96 standard deviations of the average. Okay. So using a z-score of 1.96, the population standard deviation of 2.3, and n equals 40, the margin of error is going to be 1.96 times 2.3 divided by the square root of 40, which is approximately 0.7. So we are 95% confident that the margin of error for the population average is about 0.7 hours. So then this notion of confidence intervals, a confidence interval for the population average mu. So that's going to be what? The sample average plus or minus the margin of error that it contains the population average, where E again is what we just discussed in the last slide. The critical value times the population standard deviation divided by root n. So the probability that the confidence interval contains the population average is C. So C is the confidence interval. Assuming that the estimation process is repeated a large number of times. Again, this is assuming that we do this for a large number of times. So finding a confidence interval for a population average for a known sigma. Verify that the sigma is known, the sample is random, and either the population is normally distributed or the n is greater than or equal to 30. Find a sample statistic n and x bar. Okay. So x bar is the sample average. It's going to be the sum of the x's divided by n. Find the critical value C that corresponds to the given level of confidence. Use table 4 in appendix B. Find the margin of error, which is going to be the critical z value times the population standard deviation divided by root n. Find the left to right endpoints to form the confidence interval. Okay, so we're going to say x minus the margin of error and x plus or minus E, basically. Okay. So use the data in example 1 to construct a 95% confidence interval for the average number of hours spent. Okay. We said that the x bar was 21.1 and margin of error was 0.7. So then the left endpoint is just going to be the 21 minus the 0.7, and the right endpoint is going to be the 21 plus 0.7. So then what this is saying is that we have a 95% confidence level that the population average falls between 20 and 20.4. Let's see. Okay, yeah, that's fine. So use the data in example 1 in technology. We're going to skip this one because we don't have access to this. We might be able to do this in Excel, but I'm not sure. I'm going to let that be. Let's do this one. So constructing a confidence interval. A college admission director wishes to estimate the average of all students currently enrolled, average age of all students currently enrolled. In a random sample of 20 students, the average age is found to be 22.9 years. From past studies, the standard deviation is known to be 1.5 years, and the population is normally distributed. Construct a 90% confidence interval of the population mean at age. So here our n is 20. Our sample average is 22.9. The population standard deviation is 1.5. The critical z value, so if we want a 90% confidence interval, that 1.645 comes from the chart. The margin of error at the 90% confidence level, so margin of error, we're using our formula. Again, the critical value times the population standard deviation divided by root n. You plug in your numbers and we get a margin of error of 0.6. So then the confidence interval, we want the left end point and the right end point, we got to say the sample average plus or minus e, basically. So the 22.9 minus 0.6 is going to give us 22.3 and 23.5. Okay. So we have a 90% confidence level that the population averages between these two average. So the population average is a fixed number. It either is or is not in the confidence interval. There is a 90% chance that the actual population, there is a 90% chance that the actual average is in this interval. The correct way is if a large number of samples is collected and a confidence interval is created for each sample, approximately 90% of these intervals will contain mu. So yeah. So again, yeah, and I feel like I was saying it the incorrect way. That's why I kept trying to pause, but that's what the notes were saying. Okay, that's fine. Ooh. But again, so the incorrect is that there is a 90% chance that the actual average is in this interval. But what it's really saying is that if a large number of samples is collected and the confidence interval is created for each sample, approximately 90% of these intervals will contain mu. Okay, that's fine. So for instance, the bottom horizontal bar is going to be like the population, and then we take several samples. So the shorter horizontal segments that's scattered around, those are different, a whole bunch of different samples. The dots represent the average of each sample. I think I'm reading this proper. And then what we're saying is that 90%, let me see, the horizontal segments represent 90% confidence intervals for different samples of the same size. Notice these all have the same size. In the long run, 9 of every 10 will contain the average. Okay. So if we repeat that sampling process a large number of times, 90% of them will contain the population average. Okay. So given a confidence level and a margin of error, the minimum sample size n needed to estimate the population average is going to be given by this. So let me see. Given a confidence level and a margin of error, the minimum sample size needed to estimate the population average is going to be given by this. So how many sample size, what needs to be the size of our sample in order to estimate the population average is going to be given by this formula. My bad. It's going to be given by this formula. Okay. The critical value times the population standard deviation divided by the margin of error squared. If n is not a whole number, then round up to the next whole number. If the standard if the population standard deviation is unknown, we can estimate it using S, provided that we have a preliminary sample size of at least 30 members. So it says the researcher in example 1 wants to estimate the average number of hours spent on required athletic activities by all students in the confidence. How many student athletes must be included in the sample in order for there to be a 95% confidence that the sample average is within 0.5 hours of the population mean, right? So the confidence, we want a 95% confidence level. So that means that our critical z score is going to be 1.96. with the population standard deviation of 2.3 and a margin of error of 0.5. So then we can solve for the minimum sample. We can solve for n basically. So then if we plug it into the formula, we say the 1.96 times the 2.3 divided by 0.5 squared is 81.29. So then we just want to round up to the next whole number, which is 82. So then the researcher needs at least 82 students in order to satisfy these conditions. The researcher has 40, so the sample needs 42 more members. So note that 82 is the minimum number of student athletes included in the sample in order to satisfy these conditions. Okay. So that wasn't too terribly bad, you know. So that was section 6.1. We'll go ahead. Again, we'll go ahead and make chapter 6 the last of the new material for the rest of the quarter. I will probably go ahead and load the final. I want to give you some time to try to get these assignments submitted. I don't want to do much more. I just want you to do your best. And again, I do intend to reduce or lessen the late penalty from 20% late penalty to 10%. So that way, if you want an A, you can still get it. Like, you can, even on exams, I'll probably reduce that to just 10% as well. And you know, I don't mind, because I know it's a lot of work and I'm trying to give you time to get it done. Okay, we still have a little over 2 weeks of class, maybe more like 3. But the main thing is, so there are at least 2 quizzes on Moodle. One was the participation and honesty quiz, so make sure that you get that submitted. That's part of our grade. And also there's an assessment that's also going to be part of our grade. These aren't heavy weights, but they're just part of our grades, okay? But all assignments will be posted on Pearson within a week or so for the remainder of the quarter. And you can also anticipate the late penalty to be lessened from 20% to 10%. So that means you can actually get 90% on any assignment all the way up until about May 16th. That's about 2 weeks out. Okay, then the following Monday is our last day, and I'll probably get the final loaded early. Okay. On that note, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Peace.